Hello, welcome to part 2 of the review on exponential functions and logarithmic functions. And we just went over the property in the other room just now. And so now we're going to prove these properties that we seen just a few seconds ago. And so the proof of property 1, and this is for inverse functions. Now we had the inverse of f of x. Well, you know, remember from regular functions, if you plug the inverse into the original function, you're going to get x. And vice versa, if you plug f into the inverse function of that function there, you're going to get x also as well. So f of the inverse of f of x is equal to x for all x in the domain of the inverse of f. Using this here, f of x is equal to a to the x, and the inverse of f of x is equal to the logarithm base a of x. So we find that when we plug this in, when we plug this into f of x, then here's what happens for x greater than 0. Now we let this here, x is equal to m, to obtain here a to the log base a of m is equal to m, and where m is greater than 0. So basically, when you have plugged this value in for x, so this is the inverse of f of x being plugged into f of x, the original function, then you will get x. And we know that it has an inverse. They're inverses of each other. So that's a good thing. So the proof of property 1 holds true for that case. And the proof of property 2 is for inverse functions as well. The f of f being the original function being plugged into the inverse function that we said, right? That should also come up to be x when you simplify it. And for all x in the domain of f, using the same thing here, f of x is equal to a to the x, and the inverse of f of x is equal to the log base a of x for all real numbers x. So in this case though, now you're going to plug in the original function into the inverse of that function, and so you still are going to get the answer x. So of course, as we said before, we must, if you plug in the inverse into the original function, you should get x. And then when you come back around and plug the original function into the inverse, you also should get x as well. So this is what this is saying. So this is very important. And you know that that has an inverse. Well, let's look at the proof of property 3. Let a equal the logarithm base a of m, and let b equal to the logarithm base a of n. And these expressions are equivalent to the exponential expression a to the a is equal to m, and a to the b, which is equal to n. So here what we talking about before, earlier, when we have two powers being multiplied together, in this case two logarithms, which are represented the bases, being the same, which when the bases are the same, you're going to what? Add the exponents, a plus b. So this here means that you're going to add the logs. So the log base a of m plus the log base a of n. So this holds true for the log exponents, right, for this case, and also property 2 of the logarithms, right? So let's look at the proof for property 5. So let a equal to the logarithm base a of m, and this expression is equivalent to a to the a is equal to what? M. So in this case now, the log base a of m raised to the r is equal to the log base a, right, of a to the a raised to the r. So that looks like that raising the power to a power, right? That property, law of exponents, remember that? And so r times a, which is the property, is dealing with property 2 of what? Of logarithm. So here's what's happening. Whenever you have this sort of thing happening, whenever you have, say, for example, I'm going to raise this up a bit. And so if you have, say, log, let's say log base 2, and you got this 6 to the, say, to the r power, right? you have this going on. So you know just some number, this value or this variable here has to what? Come down. So this variable will come down and become what? Log base 2 of 6. So that's what that property is representing there. Also, if you had the natural log, say you had the natural log of x raised to the n, right? Still, if you want to write this expression, simplify this expression in the sense of the matter, this will be the natural log n times the natural log of x. See? So this is how this has to be. This has to go over here, representing what? That satisfying property 5 of that, of the properties of logarithms. So that's very, very important. So seeing that this now is r times the logarithm of base a of m. Now, let's look at property 6, the proof of property 6. Okay, from property 1, with a is equal to what? To e. And e, we're going to talk about this a little bit later on, e represents an irrational number. It's a constant now. It's an exponential function. It's a constant too, right? Which represents some value on your calculator. We'll speak of that in a little bit. We have e raised to the natural log of m is equal to m. So now let m equal to a to the x and apply property 5. So here we have e raised to the ln of a raised to the x. So here we go. We had to bring that x, that exponent over, don't we? Where e to the x times the natural log of a is going to equal to a to the x. So this basically talks about the proofs of the properties that we were doing a little bit earlier. Take the time, rewind the video, and take good notes. And if you have any questions, we'll address those questions. And at any time, study hard and remember these because these will come back later on in calculus.